Okay, well, let's get started. My name's Orin Thomas. You can hear by the accent, I am Australian, so I'm a long way from home. I'm from Melbourne, Australia, or New Holland, because of course, the first Europeans to run into Australia were the Dutch, and they came and they looked and they ran into northwestern Australia, which is terribly hot, flat desert, and went, this place has absolutely no utility to us whatsoever. But there is a famous story about a plate, a platinum plate or something like that, that's called Dirk Hartog's plate, that's right up in northwestern Australia. It's a very interesting place. I actually learnt to scuba dive up there off a place called Ningaloo Reef, where the whale sharks come down. Anyway, it's not the first time I've presented in the Netherlands. I actually came here in 2011 and presented at TechEd, but it's been 8 years since I've been back. Anyway, today I'm going to talk about Azure Operations Security. And the idea about this is that for the most part, when people think about the cloud, especially from the developer perspective, they're thinking about, oh, I've got my app, and I'm only going to worry about what's going into my app. And the reality of the cloud, like any platform, is that there's a whole lot of stuff that exists beyond the underneath. And one of the mistakes people make is that they assume, especially with cloud providers, and I would be remiss in saying that I think that cloud providers allow this myth to exist, that everything's looked after for them underneath. And I call this the nappy changing paradigm. The assumption is that you will get your nappy changed for you if you deploy in the cloud, and that's simply not true. So, there's a statement here from Gartner that 95% of cloud security failures will be the customer's fault. This is a really good thing to say if you're a cloud provider. It's like complete abrogation of responsibility. But what it's really about is understanding a thing called the shared responsibility model. And all cloud providers have this. And they do make it fairly explicit if you go and read the fine details. Because what it's all about is understanding what the cloud provider is responsible for and what you're responsible for. So, to an extent, one of the sales pitches of the cloud can be that it infantilizes developers a little bit because it tells the developer, you don't have to worry about any of this. In reality, they do. So when I'm having this discussion with IT pros, what I like to come back to the IT pro and say, actually, you have as much responsibility in the cloud as you do have on-prem. The idea that it's all done for everybody, no. There's stuff that you need to look after. So what is a cloud provider responsible for? Well, our physical data centers. There's data centers all over the world. If you tried to walk into one of those, good luck. It's like walking into a military base. The operations of the data center. Anybody who works in a data center needs to be fully vetted. You just can't walk in. Even if you're going and looking at an experimental data center, you've got to be cleared to go in and look at an experimental data center. And then the infrastructure, the hardware and the software that powers the cloud, well, that's the responsibility of the cloud provider. But there is what we might call a joint responsibility, but in reality it's kind of your responsibility when it comes to things like virtual machines and networks. When I was a consultant before I came to Microsoft, I'd go into startups and I'd go and look at their cloud deployment, and they'll have deployed a whole lot of virtual machines. And the reality of the cloud is the primary deployment of things in the cloud just tends to be people running virtual machines. And you'd go and look at a virtual machine and you'd go, when was the last time you updated this? What? When was the last time you ran a software update on this virtual machine? Oh, the cloud provider does it. No, they don't. There's a perception that you deploy a virtual machine in the cloud and it's all looked after for you, but no, it's not. So often when you go in and look at people's virtual machines in the cloud, one of the first things you'll see is that they've never run a software update on it. They're running the version of Linux that existed when they deployed it. They run the version of Windows that existed when they deployed it. Apps and workloads, they're your responsibility. If you write an insecure app, it's not the cloud provider's fault if something happens. The data and the security of that data is your responsibility. We know, we have heard stories and stories and stories about people leaving storage account keys in GitHub repos that get picked up, like if you go and use Bing, which I'm sure you all use, to look for storage account keys. Oh, look, we're finding all of these because people put them in their bloody source code. Or they don't lock down the storage account. So there's all of these open storage accounts or buckets that people can go and access stuff. All of these data breaches that are occurring because people aren't securing their data. So one of the things that partly this talks about is there's an understanding on our part that we can't make you secure your cloud, but what we can do is we can provide you with really good advice telling you how to secure your cloud. You can lead a horse to water, but you can't make them drink. But what we're trying to do is we're trying to make that path to the water as easy and as well lit as possible. So cloud providers must take steps to help customers know the right measures to take to secure their deployments. And this is a challenge in as much as cloud's a whole new world. How on earth do you know what you've got to do? So, one place to start is baselines and best practices. And it's not just Microsoft, it's not just Amazon, but you can go out to third-party organisations for the Centre, like the Centre for Internet Security, the Cloud Security Alliance. In terms of Microsoft, we publish a security best practices and patterns set of pages that you can go to. And Azure Security Center, which is something I'll talk about, actually comes through and says, okay, according to ISO 27001, 8 of the 12 controls that are measured by that particular standard in your particular deployment are actually being adhered to. If you were looking at the Centre for Internet Security benchmarks, 14 of 15 controls. PCI DSS, if you're dealing with payment card data, well, you've got 31 controls. So Azure Security Center is a thing that allows you to assess the security posture of your cloud deployment in Azure. It allows you to strengthen your security posture. It allows you to look at your compliance, as you just saw, against those particular standards. It will continuously assess your security state and say, hey, here's some security controls that you haven't configured that you could go and configure to improve your security posture. And then you can optimize and improve your security by configuring those controls. For example, I just showed you the policy and compliance, and if you click down and you can drill down into those, it'll say, right, to get each one of these particular standards or to come up to compliance with these particular standards, these are the steps that you need to take with your particular cloud deployment. Here we have resource security hygiene. And what this is saying, and in this case with this particular screenshot, I'm really only looking at not a particularly complex deployment, but it's saying, okay, there's one recommendation we can make about identity and access. And I could click into that and it'd tell me, go and do this, and then you will have resolved that and you will be much closer to deploying with best practice. Threat protection is another aspect of Azure Security Center. Azure Security Center being a holistic way to look at your cloud security deployment. With threat protection, what it's doing is it's looking at attacks that are occurring against your cloud subscription so that you can be notified about whether or not there's suspicious activity or activity that really requires that you look a bit further into it. To understand the way that Microsoft assesses threats, you have to understand a thing called the Microsoft Security Graph. So Microsoft, as you're well aware, has all of these huge online properties, Office 365, Hotmail, Xbox Live, and Azure. And by running these particular properties over the course of many, many years, Microsoft has learned a lot about security. They've learned a lot about, for example, a way of assigning reputations to IP addresses. There's only a limited number of IPv4 addresses in the world. Certain IPv4 addresses will be used to send spam, will be parts of botnets, and so on and so forth. So if you've got traffic coming into your Azure subscription from a suspicious IP address, that can be flagged as suspicious activity. The other thing that the security graph does is because Microsoft has been collecting all of this security incident telemetry for so long, they've been able to apply machine learning techniques to it So that rather than in the past where you'd actually have to see a particular set of telemetry and event logs and say, oh, that looks like it's an attack, you can now use machine learning to analyse telemetry as it's coming in. And even with a new and novel attack, the characteristics of an attack can be recognised by machine learning and then passed on to security researchers to be looked at. So Microsoft's got 3,500 security researchers who get stuff flagged. It's like, oh, look, we've seen this telemetry, we've seen this particular set of probes, we've seen this particular set of events within event logs. We think, or the machine learning is saying, this is probably an attack. It's handed to a security researcher who will make that final determination. Now, once malicious activity is identified somewhere within the entirety of Microsoft's security ecosystem, it can be recognised anywhere. So an example of this is you've got things like Azure Advanced Threat Protection, which you might install on, Windows Defender Advanced Threat Protection, which you might have on your Windows 10 workstation, on your Mac, on a Windows server box. And if a particular attack is seen, let's say it's seen here in the Netherlands, and then someone tries the same attack 5 minutes later in Tasmania, it will be flagged as an attack in Tasmania because that equivalent of that virus definition has spread through that entire network, so that once an attack is recognised somewhere, it's recognised everywhere. It's not like the old days where there was a 0 day, where you could use a 0 day a certain amount of times before it was known by the virus vendors because they got the signature of it. Once an attack is recognised, it's always recognised. So Azure Sentinel is our newly announced cloud-based security incident and event management system. So the idea of Azure Sentinel is to take all of the telemetry that's coming up from your sensors, security sensors, and then to run machine learning analytics against that telemetry. So in the past, if you had a security incident event management system, you'd have a box that might sit on-prem, and it'd take all of that telemetry coming in and say, I recognise this activity as bad. Why? Because I have a list of what activity looks like that is bad, and I can see this is bad, then I will alert you. The idea with Sentinel is you go and throw all of that up in the cloud, and then you run machine learning against it. So the machine learning not only knows a set of already known bad activities, but will pick up new bad activities as they occur. And that's not something that was being able to be done with traditional security incident and event management systems. So it'll detect previously uncovered threats. It'll also minimise false positives because once a false positive is recognised, the machine learning updates itself and goes, oh, well, that's not really something that's a problem. It investigates threats with AI and hunts suspicious activities and then taps into that Microsoft security graph. With Sentinel, you can also have automated responses. Once you recognise the behaviour, you can choose to run a logic app that will automatically respond to that behaviour. So this is just a picture of the Sentinel dashboard, and we can see that there's certain particular attacks coming from different parts around the world against a subscription. We can see where your data connectors are, and you can set up data connectors to bring telemetry into Sentinel from everything through to AWS, from different SIEM checkpoint, all of these things. So the idea is to take all of this insane amount of data and bring it into the cloud and then analyse it there, because that's something that we couldn't do in the past. The cloud is really suited to analyse massive volumes of data. You can make the haystack as big as you want because the cloud is very, very good with machine learning at finding the needles in the haystack. In the past, you'd have to limit the size of the haystack, otherwise you wouldn't be able to find the needles. I'm hoping you've got that saying in the Netherlands. Yeah. So, security playbooks are once you have identified a set of behaviour and you want to automate the response to that, you run a playbook. I see this behaviour, I perform this response. So, next thing we will talk about, and something that we've seen in many, many cloud providers, and this is a really simple, just a simple hint. How do you stop someone from deleting something accidentally? We see this all the time. Well, there's a thing called a resource lock in Azure. And all you do is you set up a resource lock on a resource that you don't want someone to delete. You've got two options. You've got the cannot delete option, which allows someone to modify a resource but not delete it. And read-only means they can view it but not modify or delete it. So when you're setting something up, you're just putting a flag there saying, I'm putting this resource lock there so that you can't accidentally go and delete this thing. It's something, again, you see, one of the challenges with cloud subscriptions is you get a lot of sprawl. And then someone screams because they're looking at the bill and going, reduce this sprawl. And then someone just goes in and starts hammering stuff and going, well, I'll get rid of that. I don't know what that is. I don't want that. And then suddenly you've deleted a production database that you really didn't want to delete. So resource locks is a good way of stopping mistakes, because mistakes occur. And one of the other problems that we see a lot is, well, I've been into, again, consulting. You walk into a startup and you can see the whiteboard, and there's one account used to manage the entire cloud subscription. And the username and password for that account is sitting up on the whiteboard. So how do you stop insanity like that? Well, probably you can't. But what you're trying to hope is that at least someone's not logging on and going, well, I'm just going to go and delete stuff. Because once you delete something from the cloud, it's not like that you can usually go to backup tapes to restore it, because a lot of people don't back up their stuff in the cloud either. So how do you control who can react or interact with specific resources? Well, this is straightforward. It's a thing called role-based access control. So with role-based access control, you use the principle of least privilege to only grant the amount of access that users need to a specific resource. Rather than having that account sitting on the whiteboard, what you do is you go, you need this access, that's all I'm going to give you. You can grant access to resources, resource groups, or subscriptions. So within Azure, you have a thing called, obviously, the subscription. Within a subscription, you've got resource groups, which can contain a whole lot of different resources, and then you've got the individual resources. And you can apply permissions at those 3 different levels. So let me give you an example of how role-based access control works with a quick demo. So here I am in the Azure console, and I'm logged on as a user named Jupiter. So Jupiter here is looking at the virtual machine section of the Azure console and cannot see anything. So Jupiter is a normal user. So what we want to do with Jupiter is that we want to give Jupiter permissions to interact with a specific virtual machine. So I've logged on as myself, Orin, and I can see a VM called my VM. So what I can do is I can go in to that particular VM, and through identity and access control, I can assign the role of VM contributor to Jupiter, which will allow Jupiter to manage just that particular VM. So what I'm doing is, instead of saying, Jupiter, you're a global administrator, you can do everything, I'm saying, right, Jupiter, I'm giving you the permission just to interact with this particular VM, so that I'm not worried about Jupiter doing something that Jupiter shouldn't do. So I select a role assignment. Here, virtual machine contributor. I then select the user that I want to assign it to, which is Jupiter, and I click Save. It saves that role assignment. So I jump back to Jupiter. I click refresh. Now, eventually that will come up, but the quickest way of getting new permissions is to just sign out and sign back in. So Jupiter signs back in, puts their password in, goes across to the virtual machines blade, and now Jupiter can actually see that virtual machine. So it has enough permissions just to that one virtual machine. It might be you have 500 virtual machines and you do it on an individual basis, or you put a bunch of virtual machines in a particular resource group and then assign the permission to that resource group. So now Jupiter can go and connect to that virtual machine, restart it, stop it, capture, delete it, refresh it, do whatever Jupiter needs to do with that. You can do that, and that's the principle that you follow for all resources that sit in Azure. That you sit there and you go, right, what permissions does that person need? I will assign only the permissions that that person needs to that particular resource.
Is the user also allowed to create new resources?
You can go right as granular as you want, and you can create your own roles, where you can start off with the built-in roles, and there's about 90 built-in roles, or you can then go and create your own individual roles that even have more granular permissions. So you might say, right, okay, so you saw there I had given Jupyter permission to delete that VM. You might say, no, I don't want to give permission to delete the VM. All you can do is go in and restart that VM. You can't connect to it, you can't stop it, you can't do anything other than just reboot that VM. So, yeah. Okay, so what that does is it goes and queries Azure Active Directory, which is like your user database. So what you would do is you'd go and select the users that you want to assign permissions to from that list. Okay, so that's what you need to do in terms of when you're assigning permissions within Azure, you're using Azure Active Directory as your user database. So you can go and populate Azure Active Directory, either you can link it to an on-prem organisation using Azure AD Connect, which will then basically replicate your on-prem user list into Azure, or you can just go and create them or import them, or there's a whole lot of other ways that you can go, including trusting third-party account providers and through federation. So the next one I want to talk about is Azure Policy. So Azure Policy allows you to come through and enforce controls on your subscription. For example, let's say that you want to enforce that all virtual machines have specific password settings, that a VM has a specific configuration, that you want to limit where someone can deploy a VM. You want to say, right, people, and this is especially would be true within Europe, you've got a whole lot of regulation about where things can be. So you probably don't want people deploying virtual machines in a Singapore data center. You probably want to limit them to the European data center. So with policy, you can write a policy and apply a policy to a subscription that would limit where you can deploy a virtual machine. You could enforce the use of resource tags. Resource tags allow you to identify very quickly items within a subscription. You just search for the resource tags. And so when someone's deploying something, they must choose from a specific list of resource tags. It might be that you've got a list of projects, and when they deploy a VM or if they deploy a database, they've got to put a tag on that resource that indicates what project it is associated with. You can also enforce, for example, that all storage must be encrypted. If you're going to deploy storage, it must be encrypted. You can't deploy unencrypted storage. An initiative is a collection of policies, and there is already a GitHub repo, Azure Policy, that has a whole lot of initiatives that are already pre-configured policies that you can go and use with your subscription. So let me give you a demonstration of how this works. And in the demonstration, what I'll show you is how you can put a limitation on the VM SKUs that can be deployed within a particular subscription. Because by default, anybody can go and deploy a VM that might cost you $10,000 a month. And people aren't really careful when they've got every option in the world. But what you can do is you can write a policy and you can say, right, these are the 3 different SKUs that you can deploy in Azure, because we know exactly what they are. And if anybody wants to go and deploy something, well, these are the options they've got. They don't have carte blanche. They can only do what we want them to do. So here I am in the Azure console. I click on policy. So I click on definitions. So what I'm first going to do is create an initiative definition. And this will be the thing that contains that policy about limiting which virtual machine sizes can be used. So I give it a description. I say limit which virtual machine SKUs can be deployed. I'm going to create a category for it, and I'm going to call the category limitations. So here I look at definitions, and there's already a definition around allowed virtual machine SKUs. So I click that definition. I add that definition to the initiative, and then what I do is I populate that definition, and I say, okay, what I want to do is I want to allow specific SKUs. So here I'm going to say, right, you can do a D1, a D11, and the D1 V2 and the D11 V2. So the main thing I want you to remember at this point is that I've allowed D1s and D11s. So I go and save that. So I've created that initiative. So what I need to do then is I need to go and apply that initiative to the subscription. So here I've got my limit virtual machines SKUs that I went and created. I go and assign that. And here I'm going to choose, I can do it to a resource group, or I can do it at the subscription level, or I can do it at the management group level. So for example, if you've given someone permission to deploy VMs only to a specific resource group, you can then use a policy to say which VMs they can go and deploy there. Or you can do it at the subscription group level, or a management group level is a collection of subscriptions. So here, I'm saying do it at the subscription level. I then go through and choose the initiative. I click select. I can give it a description if I want, so that it explains what's going on, and then I assign it. Now this can take about half an hour to go through with the initial assignment. So I come back half an hour later. Okay, so now what we're going to do is we're going to go and test that. We can see that it's actually applied to the subscription. So now I'm going to go back and I'm going to go and try and deploy a new virtual machine. So I click Add for a new virtual machine. Select the subscription I want it to be in, the resource group. I'm just going to create a resource group called Example. I give the virtual machine a name. Region's fine. I'm not doing anything option here. Now we can see it's got a D2, and we've got all of these options in terms of what our options are. So I'll choose a B1S. If you remember, I had a D1 or a D11 that I allowed. Again, I'm just going to do a Linux virtual machine, and I'm just filling out a whole lot of ephemera around setting that up, username, password. I click Review and Create. Now, during this point is when the initiative comes in. And it says, your validation has failed. It will not allow me to create that virtual machine because that policy is blocking that virtual machine from being created. And that tells me it's been disallowed by policy, and this is the particular initiative that is disallowing this.
Why quickly select it?
Pardon?
Why quickly select it?
Because it doesn't come into play until you click Submit and you push it through to the engine to say, you've got that. So it doesn't evaluate the policies until you do it.
Your users to ask for bigger machines, right?
Well, it also is that's just not the only way of skinning the particular cat of creating a VM. You might be configuring it from the command line. So if you actually just named the SKU and pushing it into the command, that's why the evaluation happens at resource creation rather than limiting you. I mean, I can understand where you're coming from. I'm just explaining this is why it occurs at that particular point in time. Because you might be pushing straight to a REST API and just sending up a set of commands through a different way. So it's not that the interface will limit you. You get blocked when you actually try and do it because there's a million ways to go and do it. So by putting the bottleneck there, it's not just saying, well, okay, we've worked out how to block it through the Azure console, but if you come into the command line and you do some stuff in the command line, you get away with having your particular VM.
So this will also apply to Audit and Azure templates?
Yes. Yep. So if you pulled an ARM template, that usually with most ARM templates, you would specify which VM, but if you don't, if the VM's hard-coded into the ARM template, it's just going to fail, and it'll just say it's going to fail because of policy. And that's not the only thing. You can think of anything that you can go and configure within Azure as an option. You can then limit. For example, you could have it that you are allowed to deploy any size, but the disk has got to be encrypted, or you're only allowing them to deploy Linux virtual machines rather than Windows virtual machines. Yes. So you can block that entirely for the subscription. Or you could do that, again, you're using it with role-based access control. So role-based access controls is what permissions you have, and policy is what you can actually do. So you can say, right, you don't even have the permissions to deploy VMs. That's one way of stopping that. Or you could say these are the SKUs that you can use, and then you can have no SKUs. So that would be another way of doing it, and you can use them in conjunction with one another. But the idea is that you probably want to stop people from deploy. If you want no one to deploy VMs, you just don't assign that permission to anybody. So the next one is that privileged identity management is the idea, as opposed to someone having permanent admin rights, you only have time-limited admin rights. For example, if you've got someone who needs to go and create a bunch of users, you could have a permission that allowed them to do that at any point in time. Or, because that's actually a fairly sensitive operation, you can say, look, you can go and create a bunch of users, but first you've got to request that permission. That request has got to be reviewed and then approved, and all of that has to be logged. Or, for example, let's say someone needs to change a password. Again, you can think of all of these security scenarios where someone changes a password where they shouldn't be changing a password. So if there's a request to have the ability to change a password and you put the information in and you have to actually request that role, well, that's more secure than just having a role that can always go and change a password. So privileged identity management can also be thought of as just-in-time administration. It's sort of like taking sudo on Linux, another level, where sudo's you've got to request admin privileges and then you can kind of do whatever you need to most of the time. With this, you can say, right, there's particular privileged roles, but you can only get a privileged role. You don't have a privileged role by default. So it means if someone's account credentials are compromised, it provides another barrier for those compromised credentials being abused. So let me give you a quick demo of what that looks like. So here I am, and I'm logged in as a guy named Don Funk, who is actually an employee at Microsoft and who has got the coolest name in the world. And unfortunately, I have seen a picture of him and he doesn't look nearly as cool as his name. So I think that and in all of the books that I've written for Microsoft Press, because I've written 40 books for Microsoft Press, Don Funk basically turns up in most of them because you have to choose an approved name. And I was looking through all the approved names and I went, well, there's a guy named Don Funk. If that's an approved name, I'm using it. So there's been people that have been logging into computers for ages with the name Don Funk if they've ever gone through my exercises. Okay, so we've got Don. Now, what Don wants to do is Don wants to go and change the password of Sam. So he clicks on Sam's account and he clicks reset password. And he gets told, this password cannot be reset. You simply do not have the permissions to go and do that. So the way that Don can do that is he can go in to privileged identity management, and I've set Don's account up so that Don has permission to request the role that allows him to be a password administrator. So he goes to My Roles and it says, here's your list of eligible roles, Don. You can request a password administrator role. Not everybody can do that. You actually have to set it up and say, right, this person can request this particular role. It's not just anybody in the organisation can do that. But Don can go through and request that. Now, when he activates that role, it will depend on the conditions I've created for the activation of that role. So here I've made it fairly simple. All he has to do is put in an activation reason and click activate. But if I wanted to, I could say that the conditions were that Don had to come back and perform multi-factor authentication. That Don's request had to be approved by someone else in the organisation. So it would get sent to someone else. Someone else would have to sign into the Azure console, go into that thing, and then click approve. That John might actually have to submit information about which ticketing system the request comes from. So all of that gets written into the logs so that if someone's auditing it later on, saying, okay, Don changed Sam's password. Don says that Sam requested the password change. We can see in the help desk system that this request was actually logged. This is the ticket number. I can verify that that ticket exists in the system. And it might be that Corey is the one that approves Don's request to become a password administrator. It depends on the role and the severity of the role. It might be that for password administration, you don't require all of those hoops to be jumped through. So here, we click activate. It activates the role. And for a certain amount of time, for an hour in this case, Don now has the ability to go and change passwords. So he goes into Sam's account, clicks reset password, and instead of being told that he's blocked from that, he can actually click reset password and reset Sam's password. So that can occur with any particular privileged role. And there's, again, all of those privileged roles, and you can control membership of those roles in this manner so that a user isn't a member of those roles until they request that membership, and then for a time-limited period, they have that. You can also apply what's called a conditional access policy, and a conditional access policy turns around and says, okay, is there anything unusual about this logon? So let's pretend that Don was actually signed on from Tasmania. Now, for me, someone signing on from Tasmania is par for the course. Tasmania is only a couple of 100 kilometres from where I live. But if you were here in this office and then someone's trying to change a password and they're signed in from Tasmania, you would probably say no, right? If this is an unusual geographic location for the logon, block this person from signing in as a privileged role. Or require, for example, multi-factor authentication, because it could be that someone has decided to go down to Launceston or Hobart on a holiday for some reason. Yeah, exactly. I can't log on. Or, I like to say Bora Bora because I'd much prefer to go to Bora Bora than Tasmania because Tasmania is very boring for me. Okay, so network security best practices. This is somewhat straightforward, but this is, again, something that people don't think about. They go and deploy resources in the cloud, and then they don't think about normal things like if you were deploying a VM or a container on a perimeter network, you know how to go and protect that. You've got an external firewall, you've got a whole lot of filters and things that you deploy. But what people do is they go and throw things into the cloud, and they don't think about firewalling it. They don't think about packet filters and things like that. Well, you can go and do that. Limit traffic inbound and outbound to what's necessary. Take a multi-layered approach to your security. That is, for example, if you've got a VM, you put the firewall on the VM, inside the VM, then you might put a network security group, and then you might put a network virtual appliance. Put a perimeter network between your on-prem network and your Azure network, as well as between the internet and any Azure workload. So if you're deploying a workload there, put something there in front of it. You can use Azure Firewall or a network virtual appliance. A network virtual appliance is a virtual machine that's running something like a Barracuda or a Fortinet or whatever that's running as a virtual machine in your Azure subscription that's mediating traffic going through to your workload. A network security group is a basic packet filter. When you're configuring a network security group, what you're doing is you're saying, okay, this is a source address, this is a destination address, this is support, allow or deny. Very basic, very boring, not very intelligent because you can't use a fully qualified domain name. You can use service tags. Now, what a service tag does is, for example, if you want to allow traffic from the internet through to SQL storage, you could use those tags, but those tags are defined by Microsoft. You can't create your own service tags. Adaptive network hardening is a new feature of Azure Security Center where you go and point at something like a virtual machine and you look at the traffic that's going in and out of that virtual machine, and it'll actually come up with a projected network security group for you and say, okay, this is based on how this is being used, what you would actually do as a network security group, rather than you sort of fussing and fumbling around trying to get your network security group right. There's a thing called Azure Front Door and there's a thing called Application Gateway. Azure Front Door is something that runs across, if you've got resources deployed in multiple data centres, you'd use Azure Front Door. So if you've got something in an Australian data centre, something in a European data centre, and you're load balancing between them, Azure Front Door, and then you can use that sort of like you might use Cloudflare for TLS termination, but you can also do things like put in a web application firewall. Now, what a web application firewall does is it takes the OAuth top 10 attacks and then uses traffic analysis on incoming traffic to drop anything that looks, for example, like a cross-site scripting attack or an SQL injection attack before it actually hits the application that you're hosting in the cloud. So even though you are hoping that the applications that are deployed in the cloud are invulnerable or hardened against cross-site scripting and SQL injection attacks, you can go and put a virtual device in front of these web apps that automatically drops that traffic before it gets to your web application. Your network security best practices use Azure Front Door with Web Application Firewall to mediate across Azure regions, or as application gateway if you've just got it within one region. You can also use Azure Firewall or a network virtual appliance to further mediate traffic. Now, a network virtual appliance, usually because it's something like a third-party Barracuda or a Fortinet or whatever, usually has a whole lot of intelligence that it's doing, analysing the traffic as well. But what we're seeing more of in the cloud providers is we're seeing firewall or web application firewall as a service, where that's happening without you having to deploy a particular virtual machine appliance from a third-party vendor to go and do that. So, lock down your service endpoints. So, a service endpoint is something like storage, key vault, or service bus. So, by default, when people were deploying storage accounts, the storage account would be open globally. By locking down a service endpoint, you can remove internet access to those resources. For example, if you've got an application that needs to go and write to a storage account or to Azure SQL, by locking down that service endpoint, you can say, right, only that VM that's sitting on that particular network can go and talk to that particular storage account or that particular Azure SQL database, instead of having that storage account open to the world and then just hoping that your storage account keys are your only bit of security between that part of the application and that part of the application. So let me do a demo showing you storage account network access. So here I am. I'm going to create a virtual network. So I'll create a new virtual network. I'm just going to call it new VNet. I give it an address space, 192.168.0.0/16. And then I'll dump it into a resource group. I'll give it a first subnet, and this will be the public subnet. I give that public subnet a particular IP address range in the /24 area. So the idea is that something that's sitting on that particular subnet might be public. So I've got that virtual network. So what I'm going to do within that virtual network is then create a private subnet. So I click on the virtual network, I click on subnets, and then I add a new subnet, and I'll call that one private. So the idea is let's say I'm building out a web application that needs to write to storage. I'm going to put some VMs on a particular subnet, and I'm going to allow those VMs to talk to storage. And then the front-end VMs are sitting on the public subnet, and the front-end subnet can talk to the private subnet, and the private subnet can talk to storage, but the front-end subnet can't talk to storage. So here what I'm doing is I'm saying, okay, allow access to the storage service, and that is associated with that particular subnet. So that subnet has access to storage, but we can go further than that. So what I'll do now is I'm going to go and create a storage account. So I'll create a new storage account. I specify where I'm going to go and put it. I give the storage account a name. I'm calling it restricted files. I can just go with the defaults in terms of the performance and the account type. I don't need it to be read access geo-redundant storage. It can just be locally redundant storage. Now, when I go across to the next page, I have the option of limiting which networks can access that particular storage account. So by default, all locations can access that storage account. So if I come across here and I say, right, selected networks, I select my virtual network that I created. And then within that, I can select which subnets are going to have access to that particular storage account. So I say only the private subnet will have access to that particular storage account. So what I've done there is I've taken a storage account, and instead of it being global to the world, and this can apply to any of these things, so SQL, Key Vault, the whole thing, I can go and create these resources so that they are limited in the access that can occur to those. So again, that's solving a problem that a lot of people have, in that they go and deploy a storage account and then they don't sit there and go, wow, this is actually globally readable to the entire world. Because someone might only need read-only access. They don't need write access. You know, we've seen situations where people have created storage accounts and put virtual hard disks for their virtual machines on the storage account, and then those virtual hard disks are globally readable to the world. So what someone does is they just make a copy of that virtual hard disk, they download it to their machine, they mount it, and they can read the contents of that virtual machine. That's not exactly what you really want to do with any virtual machine that's running in the cloud. So Azure Network Watcher is a really awesome tool that allows you to go in and view the properties of a network that's running in Azure. You can monitor communication between a VM and a specific endpoint. You can view resources in your virtual network. You can perform a network packet capture. So if you've got multiple VMs running in it and you want to check whether or not particular traffic's getting through, you can do that. You can diagnose routing problems. You can look at whether or not there's a problem with outbound connections or outbound connections through a virtual private network to your on-premises environment. You can perform a packet capture and you can view all security rules to an interface. Let me show you how that works. So here we are, and I type in Network Watcher. So I click on that. So the first thing I can do, I can go and view the topology of my network. So this will tell me everything that's connected to a particular virtual network. So let's say I've got a bunch of virtual machines and I want to know what's actually connected to that particular virtual network. So we can see here that I've actually got 2 VMs connected to that network. So if you're ever wondering about what's connected, not only do I see the network interfaces, I see the network security groups that are used to mediate traffic into those particular virtual machines. Okay, so the next thing, let's say that you've got a multi-tier web application and that application needs to talk on a particular port from this VM through to that VM. Now, rather than going into that VM and then trying to test whether or not that connectivity exists, with Connection Monitor, what you can do is you can say, I want to see if there is connectivity between this VM and this VM on this particular port. I just want to see this in the Azure console. I don't want to actually have to go into the VM to do it. So what I'm doing here is I'm setting up that check. And what I'm doing is I'm setting up a check to see if I can connect from the first VM to the second VM on the remote desktop connection port. Rather than going into the VM and checking, I'm just setting up a port probe that I can then select at any particular point in time to see whether or not that connectivity exists. So I choose the RDP port, which is 3389. And I can click Add. So what that will then do is it'll give me in the console, it'll create that connection monitor. And then all I need to do to check whether or not that connectivity exists is just click on it, and I get a nice little reachable green mark. So you can do that for any particular 2 points in time. 2 ports. Okay, so Network Performance Monitor, what I can do is for a particular network, I can actually capture performance data and then have that written to a log analytics workspace that I can look at later. So I'll just create a default workspace. And that'll allow me to view performance data. So if I'm concerned about performance within a virtual network running in the cloud, I can use that to actually analyse the performance of that network and see whether or not it's performing well or whether or not there's something I need to go and investigate. What IP Flow Verify does is it allows me to again specify 2 endpoints and check whether or not packets can pass between them. So for example, here I've got a virtual machine sitting on 10.0.0.4, and what I want to check is whether or not packets on that remote desktop port from a specific subnet on the internet can actually theoretically get through to that particular port. So I've chosen 128.250.213.10, and the reason I've chosen that was actually my first IP address of a box that I used to manage at Melbourne University in the 90s. And I'm choosing to pretend to check whether or not I can actually then get an RDP connection through, and it'll perform a check and say, look, according to all the rules, that access is allowed. So then I can come back and check on a different port, because I know that I've only opened the RDP port using my network security group. So if I was checking port 80 and then did a check, it's going to turn around and say, well, actually, according to the way that you've got your network security group and firewall rules configured, I'm not allowing that traffic through. So again, it's a diagnosis tool to try and figure out, is this a problem actually at my end in the configuration of my cloud, or is this a problem that exists out, for example, somewhere on the internet? Next hop allows you to go and check, for example, from a VM, if you were trying to, for example, get out to the Cloudflare IP addresses, where's the next hop? Now, this is especially useful if you've got multiple subnets and you've got a lot of routing configured within Azure. Here it's just saying, right, well, from that subnet, you can go straight out to the internet. But it might be that you need to jump through a bunch of different networks, depending on how you've got networks configured within Azure. Effective security rules allows you to go and specify a particular virtual machine. and then figure out all of the network security group rules that apply to that virtual machine. Again, very useful if people have been going and creating complex network security groups and applying them. Here you can see which apply, and that might tell you, okay, this is the one you need to go and modify to figure out why traffic's allowed or why traffic's being blocked to that particular virtual machine. Packet capture, this is sort of like a Wireshark or a message analyzer just for Azure. And here what you do is you specify a target virtual machine, you give the packet capture a name, and then you go and configure it. So it gets written to a storage account. You specify how much bytes you want to capture. You configure your filtering, TCP, UDP, ports, local, remote IP addresses, the whole thing. You perform the packet capture, and then you can do an analysis on that packet capture later using any tool that can go and analyze packet capture data. So again, if you're trying to do that sort of network diagnostics, you can use that tool to go and perform the capture within Azure rather than trying to go and put something like Wireshark on the VM that's running in Azure and doing it that way. You can do it sort of from the interface level. Okay, so Azure Firewall is Microsoft's firewall as a service. So the idea is, with this one, you can then go and create more complicated firewall rules. So instead of it being source and destination address in terms of IP address, you can say, right, my source is www.microsoft.com, my destination is blah, on port on the HTTPS instead of saying port 80, port 443. The other thing that's really cool about Azure Firewall is that, remember I was talking about that idea of IP address reputation, that Microsoft, through the security graph, actually has a fairly good idea which IP addresses out on the internet are actually malicious. So with Azure Firewall, you can turn on an option that will automatically block traffic to and from known malicious IP addresses on the internet that is constantly being updated by Microsoft. So if there's a bunch of IP addresses out there in Tasmania that are known for hacking attempts, you turn on Azure Firewall, you turn on block malicious IP addresses, and it'll block all incoming traffic. And importantly, it will block outgoing traffic. So if someone has actually compromised your infrastructure and is trying to exfiltrate data out of your virtual machines or out of your Azure subscription, they're often trying to exfiltrate it to a known bad IP address. They're very rarely trying to do it to a particular pristine, never been used for anything bad before IP address. Because the moment that they do that, of course, then it gets onto the sin bin and it gets marked as a known bad IP address. So this is something that you can turn on. Now, the other advantage of this over a network virtual appliance is with a network virtual appliance, because it's a VM, you're only allocating a certain amount of processor resource and network bandwidth to the VM. You can scale it up. Obviously, as you scale it up, it costs more. The idea with Azure Firewall is it scales up and down as needed. So if you're under a denial of service attack, if you're under sustained attack, it will scale up to handle that. It won't get overwhelmed, and then when that attack goes away, it just goes back down to not costing you anything. So I won't do that particular demonstration, but the next one I want to talk about is securing Azure SQL platform as a service databases. And there's a bunch of different things that you can do. You can configure network level security, who's able to access the database, the threat protection, and I'll talk about what that is in a minute, and information protection, and of course you've got customer data that'll automatically be flagged. So the Azure SQL Vulnerability Assessment is a service that you can run that will look at your Azure SQL database and then employs a knowledge base of rules that will flag any vulnerabilities you've got in your configuration. It will flag misconfigurations, excessive permissions, and unprotected sensitive data, but it will go further. Let me show you how it will go further. So here I am, and I've got a database server called Rodimus. So the first thing I can do is I can turn on firewalls and virtual networks. So what I'm doing here is I'm saying, right, what I want to do is I want to limit who can access this particular database, because this database doesn't need to be open to the world, it only needs to be open to specific IP addresses. So this is at the database server level. I can create a rule name, start IP address, and end IP address. So if it's, for example, talking to an on-prem location, I can allow that through. If it's talking to a VM that's sitting on a particular virtual network, I can go and do that. So here I'm doing it on those public IP addresses. So that's the first place that we start. We just limit access based on network. So we just go and save that.
Currently, all Azure resources can access the data.
You can choose to do that if you want, yes. But you can also...
It also means other companies.
Yes, so that's where you go then and lock it down by particular virtual networks and subnets. So that's where you go and use that one, rather than just allowing access to all. So you can block it off so that that's not possible. However, having said that, there's a debate within, or an understanding within the security community. You will hear this phrase, identity is a new security perimeter. And what we're doing is we're moving away from a model where we choose to block or allow access to something based on the network address that something is coming from. So especially when you're thinking about things like serverless, when you're locking down serverless and you're locking down some of the newer services, you're actually locking them down by identity rather than network location. So a question I get very often is, okay, we've got serverless, how do I block access to serverless from this particular set of IP addresses, or only allow access to that? And in a way, it's not a wrong question, but it's misunderstanding the way that we're trying to talk about security going forward. Because the way that it has been decided to talk about security going forward is that authentication is the boundary. Because when it comes to network addresses, that is something that is easily spoofed. So the idea of blocking based on network address is problematic to a certain extent. So the industry, in a certain way, has moved past that and said, actually, what we're going to do is block based on identity. Because if you put in strong identity and authorization controls, it doesn't matter where that's coming from. And then you can then go and look at that identity and the way that it's authenticated and go, oh, this identity authenticated from an unusual location, I'll use a conditional access policy to block that authentication. So the idea is that you're controlling it at another area. So in a way, you will see more and more where you're sitting there going, how on earth do I block this at the network level? Now, my supposition on this is that this is such a difficult paradigm shift for most people to make that at some point they're just going to turn around with serverless and say, screw it, here's how you block it by particular subnet range. Because you're actually asking people to think about things in a very different way. And one of the things that we know about the way that people think about things is once they learn how to think about it with a particular framework, they find it very difficult to shift frameworks. That's why we still use the OSI model to describe networking, even though the OSI model was never actually freaking adopted, and it's a terrible way of describing how TCP/IP works. But you go and pick up any networking textbook, and we're looking at a model that was theoretical in the 1970s and never actually adopted, because what happened was the TCP/IP came along and people said, screw it, we're not going to do the OSI protocols anymore. So this is why we go, oh, we've got data link layer and network layer, and then we're up at layer 7. And it's like, well, what's going on at like 4 and so on? Oh, no, we don't need to talk about that. Anyway, so coming back to this. So we could add an existing virtual network to allow access for that particular so on and so forth. So I'll just go and cancel that out. So I'll allow access to Azure services on or off. Okay, so auditing. Auditing you should turn on for all of your SQL systems. So we're doing it here at the database server level, and then later on we'll do it at the database level. The reason that you turn on auditing is, one, the amount of data that storage that this is going to consume will be trivial, but you can't tell what's happened unless you've got a record of it. That's why you turn on auditing. We are living in a day when we can create the infinite haystack that we can go and trawl through, so make sure that you've got that auditing turned on. So I'll go and save that auditing configuration. So we've got the exemplar database that's running within the Rodimus database server. So the first thing I'm going to do is click on Advanced Data Security. Now what Advanced Data Security does is it can go through and look at the data in the database and then try and classify it for us in terms of, is this a credit card number? Is this data that's going to be protected by particular regulation? Is it, for example, an Australian Medicare number, or is it a passport number or something like that? So you can turn that on. Now the other thing that you can do, once you've chosen where to store the vulnerability assessment settings, is you can also have it scan your database for vulnerabilities. But you can then also turn on advanced threat protection. So what advanced threat protection will do is that when there is a threat against your database, it will actually come in and warn you about it. So for example, here, it will look at your database and how your database is working, and if someone is performing an SQL injection attack, or your database has an SQL injection vulnerability, or if someone appears to be exfiltrating data from your database, that is, they're systematically going through it and querying certain data, if there's an unsafe action, if someone seems to be dropping a lot of tables, or if there is unusual client logins, you will automatically be notified. So now your database server is telling you, you know what? I reckon I'm having an injection attack. Or I think someone's actually running data exfiltration, which, you know, could mean that my database is being replicated to somewhere out on the internet.
Can you set this up using immutable storage accounts? Or will it conflict with the time period that's set?
Yeah, I can't answer that one. So email me about that and I'll find out the answer for you. So we save that, and that's now put those settings in place. Yes. This is how Microsoft makes money. So with auditing, we're going to turn auditing on at the database level. So we've done it at the server level. We can also do it at the database level. And then we specify where we're going to go and push our auditing. How long we want to retain that auditing data, we click OK. And we go and save that. So if we go now to transparent data encryption, we can turn that on. Now what that means is that the data is actually going to be encrypted within the database. So for example, if someone got access to the storage account and was trying to pull it, bad luck, you can't read that data, you can't go mount that file. So dynamic data masking, what that will do is that we've now got an analysis of the kind of data that's sitting in the database. What we can do by putting in a dynamic data mask, it means that anybody who's querying that data is only going to see partial data come back. For example, let's say that we're storing an entire credit card number. It will only return when queried that particular that particular column is only going to show you the last 4 digits of that particular credit card number through dynamic data masking. So here, for example, I can go through and I've just put some sample data in there, and I've got credit card data, and here it's credit card value, but it's only, when queried, going to give me the last 4 digits of that unless that's specifically overridden. And that's a good one you can do in terms of permissions, so that you can, for example, allow someone who's sitting on a service desk to pull the last 4 numbers of a credit card without being able to pull the entire credit card. Or, for example, the database administrator being able to do that without actually seeing all of the data itself. So we get classification here, and it's saying, okay, for example, given the data in that database, you, for example, have data that might actually be classified under GDPR, stored in that database. You can also go through and do a vulnerability assessment on the database, which will actually tell you you need to go make sure you've got server level firewall rules, you've got unusual permissions that you should go and address. So this is how you can tighten up your database. And then we've got advanced threat protection, which will tell you against attacks. Remember when we said, oh, well, I think there's been an SQL injection attack, you get notified, but you'll also have it in the dashboard that someone's tried to run that against your particular database. Okay, so what can we do to improve the security of IaaS VMs? We can do a bunch of different things. The first one is just-in-time virtual machine access. The idea with just-in-time virtual machine access is, instead of always having the RDP port open or always having the SSH port open, what you do is you go into the console and you say, can you, for the next 3 hours, open up SSH or RDP to my particular IP address? So you do that through the console. It then changes the firewall rules that apply to that virtual machine, and it opens that up. For example, I use a particular VM as my lab VM when I'm traveling. Obviously, I don't want to open that to the world. So what I do is I get to my hotel like I did at yesterday. I log into the console. I say, open up for the next 5 hours the RDP port to my VM, and I go through and it allows me to do that without opening that VM to the world. It used to be when you deployed VMs in AWS or Azure that they would be open to the world, and it was always very interesting to go and deploy a Windows machine and look in the security log, because the moment you deployed the VM, people were instantly trying to brute force into your virtual machine. So just-in-time VM access allows you to do that. So I won't do the demo on that one because we're quite near where I should be allowing you to go home. Adaptive application controls. Basically what it does is it looks at what applications are running in your VM. It will then basically create a profile of the applications, be it a Windows box or a Linux box, and say, right, we will actually create a whitelist based on what we know you actually run on this particular virtual machine. So if someone tries to run something that's not on the whitelist, we will block it from executing. So it will create a profile of your virtual machine for what its normal operation is, and then if someone starts to run applications or binaries that go outside that profile, it'll simply block them from doing so. You can manually override it if there's a set of tools that you need to run on that VM, but the idea is for most people that deploy a VM in the cloud, it will run a particular set of applications and that will never change. So all it's going to do is block that from occurring. File integrity monitoring, you turn this on, and what it does is it looks at the Windows files such as the registry and Linux configuration files, and then monitors whether or not changes have been made to those files. Because again, if someone's compromising your virtual machine, what they're doing is they're going and changing certain files. So this will then flag that a change has occurred in those files, notifying you, hey look, the registry's changed, someone's gone and put an auto run in there, or someone's changed this, the way that your startup's running on your Linux machine to put a persistent bit of malware into that system. So you select the files that you want to be monitored, you turn it on, and then you'll be alerted when a change occurs to any of those systems. Now this will work for stuff that's running in the cloud, and you can also then, by putting on the Azure monitoring agent, have it monitor your on-prem systems as well for those changes as well. So a lot of these technologies, especially with virtual machines, will work on-prem as well as in the cloud. And Microsoft's approach on this is that if we can get you using our management technologies up here, and you start using them down here, you're much more likely to use our cloud than you are our competitors. Or if you want, you can use our management technologies and run it in our competitors' cloud, because you're still paying us a few bucks a month, aren't you? So Azure Software Update allows you to basically automate the process of updating your Windows and your Linux virtual machines. So you've got them running in the cloud. It's sort of like not just a WSUS server for Windows, but it allows you to use one pane of glass to make sure that all of your Windows and your Linux machines are kept up to date. You can deploy software updates to Windows and Linux computers, both on-prem and in Azure. Now, what's really cool about it is that rather than just having it scan against what's publicly available, you can run a WSUS server, or you can run your own Linux package repo and then have it assess the compliance of your Linux virtual machines against that package repo and your Windows virtual machines against that WSUS server. So it'll say, okay, you might not be compliant with the public, but you are compliant with the ones that you've actually tested in your environment and you're happy deploying. Supported operating systems, Windows Server, RHEL, SUSE, Ubuntu, and CentOS. So change tracking and inventory tracks software services, registry, and file changes in Azure VMs. So again, remember I said that generally people deploy a VM and then it doesn't go through much of a state change. Well, with change tracking and inventory, if you want to go and see what changes have occurred with a VM, you can actually just turn this on and then it'll just give you a running list of changes that have occurred. You can also track your on-prem or stuff running in another cloud. So let me show you that one as sort of our last demo of the evening. So here I am, I've got two VMs. I've got VM1 and VM2. I'll go down here and I'm selecting inventory. So I'm going to turn it on for each one of these VMs and then specify the workspace that it's actually going to go and write that data to. So inventory is now turned on for VM1, and I've got it over on here on my VM2. So here we can see nothing's changed in the last 24 hours. Why? Because we've just turned it on. And this is sort of our before state. So what we're going to do now is we're actually going to remote desktop across to one of those VMs and we're going to install Mozilla. So by default, Windows Server ships with Internet Explorer because there's nothing like pain. We go in to mozilla.org. And we can download Firefox. We can run the installer. Firefox is now installed. And it's opened up to just verify that it's installed. So what we're going to do now is we're going to go back and jump back to our workspace. And what we can see is when we go across, now change tracking by default only updates every sort of hour or so. But if we go across to inventory, we can actually configure that to update up to every 15 seconds if we want it to. Obviously that's going to generate a lot of noise. But if we go across to inventory here, what it'll tell us is it's actually picked up the installation of a new definition updates for Windows Defender Antivirus. We've updated the management agent and it can see that we've installed Firefox. So that allows us to see what's going on each of our virtual machines that's running in the cloud, and of course you can then push that down to see what's happening on each virtual machine or each machine that's got the monitoring agent that's connected through to that subscription. Okay, additional recommendations. Encrypt your virtual machine hard disks. You turn on virtual machine encryption, you can do it while they're running. This means that if someone's got read access to the storage account that holds those VHDs, they can't download them, mount them, and get access to the contents of that virtual machine. Make sure you're running antivirus software. Deploy stuff on separate subnets, and then only allow virtual machines that have internet facing to have public IP addresses. When you deploy a virtual machine, you can choose to deploy it without a public IP address. The only stuff that should have a public IP address is the stuff that you're actually connecting to from clients over the internet. You can set up a jump box architecture where you have one box that you RDP to, and then from that box you can then RDP to your backend VMs that have got private IP addresses or SSH. So you can use that architecture rather than saying, well, everything's going to have a public IP address because I need to go in and manage it. No, you just jump box your way around. And if it doesn't have a public IP address, people can't access it from anything other than a system that's already running within Azure. You can also ADDS domain join, and this includes Linux. Now, the reason we recommend this is that one of the things people do is if they've got standalone boxes, they tend to come up with shitty account names and shitty passwords because they've got so many standalone boxes that if you've got 15 boxes and each one's got a different password on it, well, then you've got to go in and change that password manual on it. If you Active Directory domain join it, you can then have an account that people can use to sign on to that particular virtual machine. And if you believe that password has been compromised, you just change it in Active Directory, and then it's changed for each virtual machine. Okay, action items. Use your firewalls, network security groups, and network virtual appliances, not NGA, to limit network traffic to only what's required. Only VMs that provide services to the internet should be assigned public IP addresses. Use privileged identity management and role-based access control to limit what each account can do. Enable just-in-time access, disk encryption, and change tracking on your VMs. Enable SQL security features. If you go to acker.ms/ASSEC best practice, you will get the list of best practices for all of the services within Azure. Thank you very much for your attention. If you've got any questions, I'd love to answer them.
I don't know exactly how it works, so I'm curious if you can tell a little bit more about it. That's called Blueprint. Saw it somewhere.
Okay, so what Blueprint is it's a way of assigning policies across multiple subscriptions. So the idea, and Blueprints will also do other things. So with Blueprints, for example, if you've got a particular configuration for a subscription, you can just apply a blueprint to the subscription, and then it'll go and populate the subscription with everything you ask. So if you wanted to, you could have ARM templates and resource groups. So you could create a blueprint that said, go and create me a resource group. In that resource group, go and deploy this particular ARM template to populate that. Now, That's at the high level. It's very difficult to get it to do all of that, because one of the easiest ways of actually deploying certain things is to actually, for example, do a resource template that might spin up a container that runs a particular script that then goes and does things through the Azure CLI or something like that. But the idea of blueprints, it's as a sort of a set of pre-configurations that you can go and apply to a subscription, rather than just sort of manually going, okay, well, I'm going to apply these 15 different initiatives and create these resource groups and then populate them with these ARM templates. In theory, where blueprints ends up is that you're just pushing a blueprint at a subscription that pre-populates the subscription to your liking, but it's not there yet.
Behind the front door services, the second step is something like Microsoft Global Network or something? Okay, so front door, there's a really great post on itopstalk.com that actually goes through what Azure Front Door does, as well as web application firewall and all of those services. So I recommend that you actually pick that one up, because that'll give you more detail, and then it'll push you into the docs.microsoft.com resources that'll actually tell you what you need to know. Cool, well, thank you very much. Oh, go ahead.
My question about policy.
Yes?
And then let's say you have a bunch of virtual machines or whatever, just the resources on your subscription.
Yes.
And then you would like to apply, just create a policy.
Yes.
In the first place, and then let's say that you would like to enable encryption on this storage account, and then does it also
So it doesn't do it retroactively. So policy, so if you've got for example, you can then query that subscription and figure out where all of the accounts where storage isn't doing, and you can do that in another way. But what you don't do is you don't apply policy and then it suddenly comes through and turns on encryption for everything. It'll do it for new stuff. It won't do it for existing stuff. Okay, so what you would do is you'd go and query your subscription to figure out where all of that stuff is. Okay? Cool. Thank you.